Hello everybody, I apologize for the late posting of this video. I wanted to take a quick look at using the program to work with binary data. As you probably realized by now, the interface is almost exactly the same as it was for continuous data, and most of what we're going to be doing is the same, so hopefully you were able to work your way through this even without the video. But let me give you a quick demonstration and highlight a couple of features. The first thing that we do is we go to the effect size, we say it's going to be the odds ratio, and then down here the program gives us these three lines: the event rate and the control group, which is basically the prevalence, the odds ratio, and after you enter those two values, the program computes the event rate in the treated group. Just to make this a little bit clearer, we can click on groups, we can name the groups. Let's call this the new intervention versus the standard intervention. And if the prevalence, let's say we're looking at the proportion of students that drop out of school, and maybe we're looking at a proportion of 40%, and we hope that the odds ratio is going to be 0.80, which means that it's going to reduce the proportion of dropouts down to about 35%, 0.348. The first thing you need to do is to make sure that these numbers are accurate. In other words, that you've entered the odds ratio correctly, and in this case we're getting a lower rate for the new group than we had for the standard group. If you expect that the event rate is going to increase, then obviously you'd want to have an odds ratio that's greater than 1. Let's assume this is going to be a 4-level study, so we go to levels, add a level, levels, add a level. We can name the levels as we did before. Let's call this district. And school. Actually, these should always be in the plural, so that's district, schools, classes, and students. And we click OK. Let's look at the spans. We right-click over here, click Enter the span of risks, and so overall the mean prevalence in the standard group is meant to be 0.4, but we think that from district to district that might vary, maybe being as low as 0.30 in some and as high as 50 in others. For schools within a district, let's assume we're also looking at a span of 20 points, so that in a district where the mean prevalence was 40%, the prevalence in any given school might range from 30% to 50%. Obviously, in a district that had a lower prevalence, let's say in a district with a prevalence of 30%, then the school means might vary from 20% to 40%. And let's assume for classes within a school that there's relatively little variance, that in a school where the mean prevalence was 40%, that the dropout rate might vary from 35% to 45%. All of this applies to the standard group. We're assuming that the same spans are going to apply to the treated group, or in this case to the new intervention, except obviously they're going to be based around a different mean risk. So we can close that. The span of effects doesn't enter over here because we are not using blocking. For the time being, I'm not going to use any covariates. We're going to come back to that next week. Let's assign costs to this. Let's assume that every district we go to is going to cost us $5,000, and every school we pick within the district is going to cost us $4,000, and every class we pick within the school is going to cost us $1,000. And then for students within a class, let's assume that for students given the old treatment, it's going to be less costly, so we're going to say set the cost of students for each group separately. For students in the new treatment, it's going to be $1,000 per student, and for students in the old treatment, it's going to be $200 per student. So there we have the basic outline. of this, we can click Optimal Design Wizard, Compute, and the program shows us that, this was a fairly small effect. This is going to cost a lot of money. Well, there's not much you can do about that. Why don't, just to make this a little bit more optimistic, why don't we set assume the odds ratio was 0.70, and we go to the Optimal Design Wizard and compute. Okay, well, that looks a little bit better. Obviously, I'm not suggesting that you manipulate the odds ratio just to get the power that you want at the cost that you want. What I am saying, though, is that in this case, if you wanted to do a study and power it for an odds ratio of 0.80, you'd be spending a lot of money chasing after a relatively modest effect. On the other hand, if you were looking to power this for an odds ratio of 0.7, which is really about an 8-point difference in dropout rates, then it would cost you it would cost you about $1.7 million. We can paste those numbers in, close it, they show up over here, and that's done. You can then obviously create a report or a graph. Let's say that we'd like to know how much this would cost us to power for an odds ratio of 0.6, 0.7, or 0.8. We can go to the graph, and we can say series, odds ratio. We had 0.7, we're going to add one more. We have 0.7, 0.6, 0.8. We click OK. And this obviously is power for an odds ratio of 0.6. And we see that to get power of 80%, we would need 19 districts at a cost of, I'm sorry, that's for an odds ratio of 0.6, which it says over here. To get power of 80%, we would need 19 districts. The cost would be a little bit under $1 million. For this line, we would need 36 districts. That's an odds ratio of 0.7. The cost would be about $1.7 million. And to power for this one over here, which is an odds ratio of 0.8, we would need 89 districts at a cost of $4.3 million. As before, we can go back and add the cost to this so that it's easier to see. We can remove the footer so we have more space to work with, and so on. Something else we might want to do over here is check out different values of the prevalence. Let's come back over here. Let's assume that we set this for an odds ratio of 0.7, and we're assuming the prevalence is going to be 0.4. But what if the prevalence is actually a little bit lower than that? How is power going to be affected? Create a graph. Series is going to be the event rate in the control group. We had set it at 0.4, but let's say it's 0.35. Click OK. And what we see over here is that it matters, but it doesn't matter as much as I would have expected, so that for the prevalence of 0.4, which is what we were working with, we would need 36 districts at a cost of $1.7 million. That's what we saw earlier. But for a prevalence of 0.35, we would need about 40 districts, which is not that much worse, at a cost of 1.9. As always, once you decide on that, you want to go back and rework the optimal design, because the other numbers can change a little bit. Over here, if I change the prevalence to 0.35 and run the optimal design wizard and click compute, I end up with a total cost of $1.936 million, so it really has not changed very much. Okay, ignore this for now. I'm going to be discussing this next week in substantial detail. Let's assume for a minute that that we're going to work with a study where we block at the top levels. It's the same idea as before. I'm going to click Randomize Classes. I am going to set a cost for the districts of $5,000 and a cost for the schools of $4,000. And optimal design. I forgot to do one thing. The additional thing we need to do over here, of course, is to set the span of effects. And this is something which is different than in the continuous case. What we really want to concentrate on over here is the span of the odds ratio. So as I change this is in a log scale, the span, and the tau square is in a log scale. Those probably are not going to be terribly intuitive for you, but what you can do is simply click this and see what happens to the range of the odds ratio. So let's assume we're talking about an odds ratio of 0.70. Let's say that we expect that it's going to vary from a low of 0.6 to a high of 0.8 approximately. So we simply click this until we get that 0.6 to 0.8. And then for the schools, we expect that in a district where the odds ratio is 0.7, that this might vary from 0.6 to 0.8 again. So we've got those spans. Having done that, we can go to the Optimal Design Wizard, click on it, and get a design. Okay, that's the basic way of working with this. This over here is important, but I really want to dedicate a large part of the fourth week to that. So for the time being, just let it go, and we'll talk about it next week. Thank you. Please send your feedback and any questions that you might have.